Example here, number 2. It tells me that the atomic number is 74 and that the charge is +5 and the number of neutrons is 109. So what can I start with on that? Well, the atomic number 74 is a key identifier. Remember, it's just as important as your social security number. So let's go to the periodic table and find number 74. I'm going to slap my periodic table around here. Hopefully you have yours in front of you. If not, you can always Google atomic number 74 and you probably find it. So even if you're without your periodic table, you could look it up in a hurry. Here I've got, in the middle of your screen here, tungsten, one of my favorite elements out there. It's got the highest, I think the highest melting point of any metal. Pretty amazing. It's not why it's my favorite, I'll tell you about it why later. But in tungsten then, 74 is atomic number in the upper left corner. We've got tungsten, the name, and we've got W as the symbol. So let's go to, or as the abbreviation. Let's go back to our page and fill in what we know. So we know that because it has atomic number 74, we looked it up, and that is tungsten, T-U-N-G-S-T-E-N. Tungsten is the metal found in those little filaments in your old light bulbs. Nowadays you don't see as many filament light bulbs anymore, but that little wire that you see in there is usually made of tungsten. So we'll put the symbol in that abbreviation of W from our periodic table, which we'll need here in a little while. We also know that the atomic number 74 here always belongs in the bottom left corner. So that was given to us. We're going to put it down here. All right. And what else do we know? Well, this positive 5 charge that's given over here is also going to show up in the symbol in the upper right corner. So I'm going to stick a 5+ in up there. Now there's some information missing, of course, and we're going to fill that in as we go. What else do we know about this? Is it an atom or an ion? Well, it's got a charge of +5, so it has a charge. It's not neutral, so we would call it an ion. Remember, an atom would have no charge. It'd be neutral at 0. How many protons does this atom have? Well, remember the atomic number 74 tells us the number of protons, so that's 74. Those two are always equal. Atomic mass. Let's talk about that for a second. Remember, atomic mass is which two pieces put together? Protons and neutrons, the two things that have a mass of 1 AMU each. So we add the protons plus the neutrons to put those together and get the atomic mass. So in this case, I have 74 protons, which we figured out from the atomic number, and 109 neutrons, which I was given. Let's add those two things together to get our atomic mass of 183. Simply 109 plus 74. And that atomic mass not only goes in this middle box, but also goes in the upper left corner of our symbol to finish it out, 183. All right? Last thing to figure out often is electrons, and here it is again, our last thing to figure out. Now, this charge of 5+, remember, means that in our finished ion, there are 5 more protons than there are electrons. 5 more protons, because 5+ means the positive side is 5 more than the negative side. My proton number is 5 greater than my negative electron number. It makes that difference of 5+ in there. And so how many electrons does that mean? Started with 74 and I lost 5. Well, 1, 2, 3, 4, 5 to get that 5+ charge. So 74 minus 5 leaves me with 69 electrons total. Okay? So 74 positives and 69 negatives next to each other. If you were to think about them as a stack of positives next to negatives, the positives would be 5 steps or 5 protons higher than the electrons, and that would give me the overall 5+ charge. Protons are greater than electrons when the charge is positive. Protons are less than electrons, or you could say electrons are greater when the charge is negative. And we'll look at an example like that as well. Hopefully those two make sense to you. I want to run through one more example with you just to show you an atom. Let's slip down here to number 8 on your sheet. It says that this is an atom, and so we know it's neutral. If you're told it's an atom right out of the gate, then you can go ahead and say the charge will be 0, because overall atoms are considered to be neutral here. The other thing we know, without going any further into what element this even is that if it's neutral, the protons, which are given to me as 43 here, and the electrons have to be the same because they cancel each other out. So 43 protons, and I know it has also 43 electrons. Now I don't know what this element is yet. I haven't gone to look. Okay, but I know that it has 43 electrons because that has to be equal. Now what element is this? Let's jump over to our periodic table and take a look. Okay, 43. Oh, right here in the middle of the screen again, not too far from tungsten, is element number 43. Technetium or technetium. This element is outlined, you'll notice, from the periodic table. And if you do a little digging there on the bottom of your periodic table, you'll see that the elements that are drawn or written with only an outline mean that they were synthetic or made by people in laboratories. In fact, technetium was the first such man-made or synthesized synthetic element quite a while back. So number 43 is technetium. That's a mouthful. Let's put that one down over here on our sheet. Number 8, technetium. Okay. And what do we know? On our periodic table, it's a TC. Be really careful with those abbreviations, because often if you use the wrong letters, you'll be a whole different element altogether. So TC. We know the number of protons is 43, and that tells us what else? Well, hopefully that tells you atomic number. So that's also 43. And that 43 goes down here in the bottom left-hand corner of our symbol. Atomic mass will be protons plus what? Neutrons, hopefully you said. And so protons plus neutrons. Protons is 43, neutrons is 56. If I put those together, I get a total mass of 99 AMUs. And that number 99 goes up here in the top left corner. Okay? That's it. Our row is complete. No charges to deal with because this was a neutral atom. And from there, it's pretty simple. So atoms are probably a little bit easier than ions, but not a whole lot. And they look a little bit simpler in their overall symbol as well. Now, hopefully I've told you which of these on this page I want you to have ready to go next time we look for problems. But we'll be giving you some time. I'll be giving you time in class to work on these, I suspect, the next time out. So unless you've been told otherwise, if you've got these few examples down, feel free to try some if you want, even just a row or two, and check them with me in class, or come back to class next time and work on them there and get your questions asked and answered. We'll see you then.